Here we have an inverting amplifier circuit wherein we have provided an input voltage of 5 volt with 40 hertz frequency, and the signal is an AC signal that we are going to apply, and this is the maximum limit of the power supply, plus 15 and minus 15 of the op amp. And we have applied a feedback resistance of 3 kilo ohm and 1 kilo ohm value of resistance R1. So to compute the output voltage, it is computed as resistance in the feedback divided by the resistance which is connected to the inverting terminal, that is 1 kilo, multiplied with the input voltage. And input voltage we have applied it as 5 volt. So that gives me a maximum value of minus 15 because it's an inverting amplifier, so that is why we have a negative sign. So negative sign implies that the output will be inverted with respect to the input. So that is observed here in the waveform. The first waveform shows the input signal, whereas the second waveform shows the output signal. And we can see that corresponding to each input we have an inverted output. So at different points we can observe the output waveform. Though we say that the output has to be limited by the power supply voltages, in this case, practical cases, we see that the output voltage will be equal to the power supply, maximum limit of the power supply. Now we will change the values of the resistance that we have connected in the feedback path. So I'm going to change the resistance R1 to 2 kilo ohm and the resistance in the feedback path to 6 kilo ohm, and I will check out the output. I will keep the input same, so that will be kept as 5 volt, and you can see that minus 6k by 2k will give me a value of 3 multiplied by 5 will give me a value of minus 15. So in this case as well, the value of output voltage is equal to minus 15 volt. That means that when the input is applied, output voltage will be inverted with respect to the input and having a value of minus 15 volt. So here we can observe the RMS values of the input and the output voltage at different points. Next, what I will do is I will change the value of the resistance in the feedback path to say 4 kilo ohms. So 4 divided by 2 into 5 will give me a value of minus 10. So when I run it, you can see now the output voltage is 10 volt. And this output voltage will vary, and the circuit also shows the way the current flows in the circuit. If you observe, into the op amp input terminals there is no current flowing. That is because ideally we consider the value of the input bias current to be equal to 0, and that is very clearly evident in this particular circuit. You can see the flow of current. It is from the sinusoidal signal through the feedback path from the output and back to the input.